Hello and welcome back. In this session we have done the main operators of the GA, crossover and mutation, so we have to determine what we should do for the next generation. In general, we have to implement some procedure to ensure that our next generation would be more proper than other generations. So at first we have to append all new populations to the one population. So we have a pop M and pop C. So we have to define one matrix and put all pop to this matrix, and then for the next step we have to sort them based on the const function. So the best const function would be on the top and the worst const function would be on the bottom. And then we have to triangulate. It means that we just add all population to the matrix, and we have to just select the best population with the size of n pop. This procedure is quite important because it's just guaranteed that the best population would be maintained to our procedure and our metahuristic algorithm. So let's just consider that we have 3 pop here. This is our pop for our initialization, and then we have just obtained the pop C for the crossover, and we have just obtained the pop M for the mutation. And then we have to append all this population to the one matrix. So we have a pop C and pop M. Just bear in mind that pop C has 2 columns, so we have to convert it to 1 columns, and then we have to sort that. As you can see that maybe that the best position maybe from the pop or pop C or pop M. So we have to select the best pops with the n pop position, and then the other pops we just deleted. So at the end of this procedure we use triangulate. It means that we just selected this pop as a next for the next generation. This procedure would be quite important, and we have to done this procedure at the end of any iteration. So let's just code this idea to the Matlab. So at first we just go to the BGA. This is our code, and this is our main loop. So here we just done the mutation operators, and we have a crossover operators. So we have a pop C, pop N, and we have also pop. As you can see that pop C would have 2 columns here, so we have to convert it to 1 column. So we use this code for converting pop C to 1 column. Pop C would be equal pop C with these 2 columns here. So it's just add comment here. So we just add a comment to this line here. At the next step we have to merge all population to the one matrix. So we have a pop here would be equal pop C and pop M. Add comments here. And for the next step we have to store the cost of population to just one matrix. So we have a cost here. Would be equal pop.cost. And then we have to just sort this cost. So add comments here. And as you can see that the first argument of this function would be just tell us that which index would have the best costs. So we can just add the sort index to our population and ensure that our new pop would be sorted with respect to the best cost. So we have this code here. And then we just use the best population based on this cost function. So we have to just select this pops with the size of n pop. So pop would be equal pop with this just size. It means that we just selected the best pops and just delete the other. So we just have selected the best pop for the next generation, and then we have to store the best position here. As you can see, we just sorted all pops. So the first pop will have a best cost. So our best cost here for this iteration would be pop1.cost, because we just sorted based on the cost function. And then we can just display the best pop for this iteration here at the end of this loop. So we can use this formula here. Firstly, we have define the number of iteration. Since we just want to use a string, so we have to just convert the number of iteration here. The number of iteration is numeric, but we just wanted to use a string, so we have to convert it. So num to str can be used here for it. And this cost is, so we have to use num to str again for the convert the base function to the string, and using in this line. So I think that we just done our code, so let's just try it. So we have an error here. You have it. Sorry, just modify this part of code. So we have a pop C with 2 columns, 6 by 2, and we have a pop C just 12 by 1. So we just converted 2 columns to 1, and we have a pop with this size 20 by 1, and we have just merge all pops to just one, so pop would be 38 by 1, and we have obtained all costs here. We have a matrix with the size of 1 by 38. So this is the cost of all population, and we just sort it based on the index and the sort cost, and then we just sort all population with respect to this sort index, and then we have a 38 population here, so we just selected the best of ones with the size of n a pop. So here we have a 38, and then we have the just 20, so the remain worst population just deleted, and then we have to store the best cost here, and then we have to display our solution at the end of this iteration. So let's just run this code here. Sorry. So as you can see that our code works, so our code is not so challenging. Let's do change our value to 100, it would be more challenging for this problem. So run BG again. So as you can see, it's just the best population for the first iteration would be 41, and it's improved. And for the last one, the best population is 2. And we can also add more variable here and add some more iteration here, 500, and it would be 50. So let's just see what's happened to our code. So as you can see, that just works. So let's just add the plus solution to our code. Here we can just add the plus. So here we have to firstly add the figure 1, and we have a plot best cost. So let's just run it and see what's happened to our code. So as you can see that our plus just shown the convergence to our cost function. So we can add the number of iteration and the cost function here to the X label and Y label. So let's just add this change to our code. Here we can add X label, which is number of iteration, and we have a Y label. So let's just run our code. As you can see that X label, which is the number of iteration, and the cost function are added to the X label and the Y label. So thank you very much for your attention. See you next. So as you can see that we have added this X label number of iteration and Y label cost function. So this is the end of our first version of the GA. Thank you very much for your attention, and see you next session.